Hi, welcome to another video, PiPad Mathematics. I'm Professor Lamb, and it's kind of funny. I'm doing this video again. I went through. It was gold. I did this video, 15 minutes of my life now. Did not get recorded because I didn't properly hit the record button on the computer. So all of you, few people that do watch my videos, hope you get a little laugh about that. But it'll allow me to get through this maybe a little bit faster because I don't have to write some of the stuff that I already have on the screen. But this video is going to be on some problem solving, PiPad problem solving. It's a popular problem in the sense of you get a target and you get different areas on that target that have different values, and when you throw darts at it, how many totals can you make by throwing, say, 3 darts at it or 4 darts at it? And so here's a simple thing. You draw a target, a nice little kind of 3-circle target here. I give values. Notice bigger numbers go inside, and then the next size up 5, and the next size up is 3. Then you have students say, if I threw darts at these, all 3 of them landed in the area, so all 3 land in the area. How many possible totals do I get? Now this is paper and pencil. You give students this, they can work the problem. I like to introduce problems, not so much paper and pencil. I like to introduce problems with some kind of action, some kind of connection, if you will. And so what I do is I have on this iPad app, I got this, it's an app, it's called PhotoDart. Now PhotoDart was designed mainly to put a picture of your boss up there, and you can throw darts at your boss. So I use it for educational purposes. And what I like to do is you take a picture. Say I took a screenshot of what I just showed you on the app, explain everything, and then I go in and I load the picture, and then I can center the target around kind of the center of my photo here, click OK, and then with students I can have them actually throw darts. Oh, bullseye, good job, good job. And so all 3 of them landed in. I got points. I can total it up. I have a 3, I have a 5, I have 2 3s and a 5, so that's going to be 11 points. We have students record. I got 11 points. That's great stuff. We do it again, and what happens if, you know, we get 2 of them that don't land on the target space? Now, the problem on paper and pencil said all of them landed inside the target. Now, that's, math teachers do some things. We give people problems, and we say this is real world. And in reality, not everybody can hit the target. So let's make it realistic. You get 0 points if you don't hit the target. So now instead of just having 3 possible sums, 3, 5, and 9, you have 4 possible point values. You got a 0 involved in there, and when you're recording how many points that you have total, you got to include the 0. So we go back to the other app, the Explain Everything app, and I'm going to flip this kind of down. My screen kind of messes up whenever I go back and forth from the portrait to the horizontal arrangement of my iPad. So here we are, and I've already gone through a set. You have your possible outcomes. You can have a 3, 5, 9, and then you have your wonderful 0 right there. And I said outcomes. These are when you throw a dart, the possible point values that you can get. And remember, we're trying to find out what are the possible totals. Okay? So with the possible totals, you throw a 0 in the mix. Then what if you got all 3 zeros? 0, 0, 0. So my total is going to be 0. I'm going to change this. So my total is going to be 0 for that one. And then you have a 0, 3, and a 5, and then my total for that's going to be 8. Now I got a 0, 3, and a 9. My total is going to be 12. 0, 5, and 9. Total is going to be 14. Then you start 0, 5, and 3. What if the second one I got a 5 and the third throw I got a 3? Well, up here my second one was a 3 and my third one was a 5. Point total was 8. Point total was 8 here. We don't need to count this one because we're trying to find all the possible totals. All possible totals. So if you have all possible totals, we already got a total of 8. We don't need to replicate it. I don't got an 8, don't need to replicate. So we don't worry about that one. Then we have a 3 and a 3, and that gives you 9, 5 and a 5, and that gives you 10. So in this case, order doesn't matter. Okay, if you get a 3 and a 5 in there with the 0, it doesn't matter how the order is. If you got a 0, 3, and 5, and you can throw a 3, 0, or 5, or 5, 0, and 3, it's those 3 that give you that possible total, so you don't need to worry about it. This is the difference between permutations and combinations. That's the idea of this problem, to get students thinking about that in an experiential way, and making an organized list. Problem solving, organized list, get students to do that. Okay, this works it out. So you go through all the possible items, you get 2 zeros, you got 0, 0, 3, so the total is 3, 0, 0, 5, so forth and so on. And that's why I did the arrows down, arrows down, arrows down. Then you get a total. Having students come up with a total, important. Having students come up with the answer, important. What I think is more important is the work they put into getting that answer, is that process, that method, that system that they went down. I like to say I want students to get to Dallas, and I want to know how they get to Dallas. Now I'm from Texas, so everybody kind of maps their way to get to Dallas. Well, I just want you to get to Dallas, and I want you to tell me how you got there, because sometimes you may take a detour scenic route, you still get to Dallas. It's important that you get to Dallas. I want to know the scenic route, because sometimes the scenic route helps you solve a problem later on. Got a whole thing on that. I'll do a video on PiPad mathematics about my kind of philosophy of that, getting to Dallas. Point is, you want to expand it. You want to do a problem like this and then engage them a little bit more. And so what I like to do is I like to use Tangrams. If anybody knows about Tangrams, they're kind of the Chinese puzzle. There's an app out there called LetsTan. LetsTan, LetsTan, and it gives you different puzzles that you can make. You use the 7 Chinese tangram pieces. You make a square, you make a rectangle, you make some funny shapes down here that you never made before, and then you make that square. And what you do with that square is you take it back to your PhotoDart, and then you change the photo after they've made the square, and you explore it and things like that. After you make the square, you go in and say, alright, now here's my dart board. I'm going to reload, and now I'm going to throw a dart at it, and then boom, I hit there. I hit the orange piece. Well, how many points is that? I don't know. And that's what you want to pose to students. How many points is that? I don't know. Well, let's figure it out. Let's find out how many points this is going to be worth. And so you bring that square back over to your wonderful app here, and I'm going to bring it up. So you go to your Explain Everything app. I'm going to pull in my existing photo. Here it is. I'm going to make it a little bit bigger, bring it to the middle, hit done. I'm going to, of course, come here a little bit more, make it bigger again. And so here it is. We got to find a value. We need to assign values to it. And what I like about LetsTan is you can do exactly what I'm doing here, and I can do distances. I can do measures. Okay, and so here are these measures, and I can now use this because it gives me a unit of measure, and I can assign value. And you notice this length is 4, this length is 2, this length is 2. So now, of course, you can't really find out what this length is right here. That's a wonderful thing about this problem. You can get some high school kids to come in there and you can figure out the length of that. It's going to bring in some nice little irrational numbers at times, which is not altogether a bad thing. So anyway, we come in here and take our green triangle. And our green triangle here is got a length 2 on both sides. And so you multiply those, base times height, you get 4, divided by 2, you get 2. So the area of this triangle is going to be 2. You'll notice that these smaller triangles, each one of those fits into the green triangle twice, so each one of those values are going to be 1. This green square has the same area, and the yellow parallelogram's got the same area of 2, and then the bigger triangles are going to have areas of 4 because they are 4 times as big as the smaller triangle. But what we're trying to do is we're trying to make a value or a target to throw darts at. And with dartboards, the smaller areas have bigger points. Well, in this case, our smaller areas have smaller points. We don't want that. So we go and we adjust it. We come in here and we adjust it to where the bigger triangles are going to have a value of 1. The smaller triangles then have a value of 4. And we take a picture of this. We go over to our PhotoDart and we change that picture in. We find it, and there it is, and we zoom it in a little bit. We fill in that area right there. We hit OK. We reload our darts, and then now we can now have a new set of problems to where we have a new set of problems with different possible point values and finding out what are the total, what are the different ways that we can get, what are the different possible totals. And this throws a whole other kind of level of thinking with the different number of 2s, the different number of 4s, and things like that. So challenge your students, get them to problem solve, use the new technology to teach this old mathematics. And I hope you as a teacher of mathematics can go out and use something like this to inspire kids to get them to think about mathematics. Thanks for watching. Again, this is PiPad Mathematics, and I'm Professor Lamb.